let's look at this projectile motion question. Okay, we are told that a projectile is launched off a cliff, okay, of unknown height. It's launched at an angle of 30 degrees, and the initial speed, u, equals 10 meters per second. Okay, that's the speed that it's launched with up at that direction. And already seeing this type of question, we should be prepared to use a few different equations that we're familiar with. We should be expecting maybe to have to decompose this velocity into horizontal and vertical components. Okay, it's a pretty standard thing to have to do for projectile motion question. And maybe use some of our equations of motion. Okay, v equals u plus at, v squared equals u squared plus 2ax, something like that. All right. What are we being asked to find? We're being asked to find this distance, how far it travels from the base of the cliff, and we're being asked to find how far does it fall. Okay, we're told that it spends 2.5 seconds in the air, so it's in the air for 2.5 seconds before it hits the ground. All right, how are we going to start? Well, as per usual, we're going to start by dividing this up into its individual components. Okay, if we divide that velocity into its individual components, uv, the initial vertical velocity, and uh, the initial horizontal velocity, 30 degrees and 10 meters per second. Okay, and so those are the two components of the velocity that go to make that total velocity, horizontal and vertical. And to find one of those individual components, we need to use trigonometry. We need to know which trigonometric relationship we're going to use for each of them. We're going to need to use both cos and sine, and should hopefully be able to see that cos 30 adjacent over hypotenuse, so is over 10. So equals 10 cos 30. Okay, and similarly the vertical velocity uv equals 10 sine 30. Okay, and I can plug those into my calculator and work out what those numbers are equal to. What is cos 30, what is sine 30, multiply them by 10, find those components of the velocity. Okay, I'm not going to do that right away. Now, if I want to find out how far it travels during that 2.5 seconds, it's actually a very easy calculation, very simple calculation, because we know that that horizontal velocity is constant, okay? It doesn't change horizontal velocity throughout the movement. So we need to now just combine this horizontal velocity and this time to find that distance. So velocity equals distance over time. Well, distance equals velocity multiplied by time. Okay? So I'm going to use that horizontal velocity, 10 cos 30 times 2.5, okay, equals 25 cos 30, and then plug that into the calculator. If you know what cos 30 is, you can find that answer relatively easily. So for horizontal distance, go back to that fact, that basic fact, we know that the horizontal velocity does not change. Okay? Now, what about finding this height that we've fallen here? Okay, slightly different approach is needed. We have to say, okay, now we know that the vertical velocity isn't constant. There's a few different things we could do. We could divide this flight up into a vertical component, saying that the initial vertical velocity is this, okay, and at the top there we know that the vertical velocity is 0, and then we could work out how long it takes to go that distance using x equals ut plus half at squared. No, v squared equals u squared. No, v equals u plus at. Just by using v equals u plus at. Okay, and then we could do a similar thing to work out how long it would take to fall that distance, and then calculate based on that. Unfortunately, that's too complicated. Let's not do that. All right, we're going to instead use use this equation, x equals ut plus half at squared, and we're going to find it out directly from that. This x here is the displacement, the distance travelled from the initial point, okay? And if we're talking just in the vertical plane, using the vertical velocity and the vertical acceleration, which is the acceleration due to gravity, then the displacement after 2.5 seconds, it has gone from being at this height up 2.5 seconds later, it's at this height. And in the vertical plane, it's gone this distance, okay? So after 2.5 seconds, the displacement is the height of the cliff. So we plug those numbers into the equation, the initial vertical velocity, the time it spends in the air, which is 2.5 seconds, the acceleration due to gravity, and again the time, and we get the answer straight away. So we can do that. We'll put in 10 sine 30 times 2.5, okay, plus half times the acceleration, which is 10. Now, I've made this positive, okay, I've made this is going to be a positive number. This velocity in the vertical direction is going to be positive. The acceleration is in the opposite direction. The vector for acceleration is downwards. So this here should in fact be negative. Okay? Minus half times 10 times t squared, 2.5 squared. If you plug that into your calculator, you'll get the answer. Okay? Always remember that if your velocity starts out upwards, then your acceleration is going to be negative.